Hello Legacy students, Marsh here. So today we're going to look at AA Similarity, so a way to prove two triangles similar. What you're going to want to have on you, your notebook, a calculator, and then a little booklet that we made in class together. That booklet looks something like this. Yours is colored, but get that out, find that, it should be in your backpack probably somewhere. You're going to want to use that to take your notes today. So go ahead and open up the first page. You should see this on the left and the right. So the definition of AA similarity, what does that mean? What does AA similarity mean? Well, what it means is you can call two triangles are similar if two angles are congruent. So if only two angles are congruent, we can call the two triangles similar. Now, because of that, all sides are also going to be proportional, which means they're going to be into a ratio. So keep that in mind. So basically, AA similarity today is noticing that there's two angles congruent, so they are equal, or they have the little circles in them, and then all sides are going to be proportional based on that. So if I look here on the right, notice how angle A and angle D are congruent, and angle B and angle E are congruent. Thus, I can say these two triangles are similar to one another. So we're going to write our similarity statement, kind of like when you guys wrote your congruence statements of triangles. Going to look exactly the same, but just a different sign in the middle. So I'm going to say triangle. I'm going to go, let's go CBA. So CBA. Now, to say that they're similar, you know how you congruence, you wrote with a little squiggle and then the equal sign? Similar is just the squiggle, just a little squiggle guy. Now, let's go ahead and write it the same way. So I went CBA, so it looks like I have to go FED. Like that. Go ahead and turn to the next page here. You should see example 1. Now we're going to identify, are these similar triangles or not? Well, the first thing I notice, guys, is that I have a right angle right here, right? And this is a straight line, so that means I should be able to mark this in as well as a 90-degree angle because they're sharing that. Well, notice now we have an angle right here congruent to an angle right here, and these two right angles are congruent to one another, right? Because two 90-degree angles are congruent to one another. So that means these two triangles are in fact similar to one another by AA. No, so I'm going to say they are similar. And since we're going to have other ways that we're going to be able to call them similar, I'm going to actually put the way we know that. So that's by AA at this current time. That's the only way we know that, unless we have all angles congruent and all sides proportional. That's the other way we can call it as well. But AA is kind of our shortcut. Now let's write our similarity statement. So I'm going to start in MQN. So MQN is similar to triangle. So in MQN, looks like I need to go OPN. So if I go one motion in the triangles, I have to do the same motion on the other one. So I'm making sure that I'm running through it correctly. Alright, let's look at example 2. So I have these two triangles here. I got some measurements inside of the triangles. One thing I notice, it looks like, guys, we're missing an angle. But notice, we already have two angles congruent to one another. But 77 and 55 are not congruent. Here's the thing. Don't just jump on and say, nope, not congruent. No, not a second pair of congruent congruent angles. Because we don't know about C and D yet. But I can figure out about C and D, right? Because how many degrees inside the triangle? 180, right? So 77 plus 48 would be 125 if I add those two together. So if I do 180 minus 125, just so I can get angle C right here, we'll get, ones cancel. So we'll get 55 degrees right here. Notice, guys, we now have congruent angles there as well. So be very careful. If you're giving two angles measures, find the third angle measure using the all angles equal 180 in a triangle. Now, since I have 48 degrees congruent and 55 degrees congruent, I can call these triangles similar based on AA. So I'm going to write my statement. They are similar by AA. Let's go ahead and write our similarity statement. So I'm going to go 77, 48, 55. So ABC is similar to triangle. Well, this would have to be 77 degrees, right? So that's the only one we didn't go to. So that would be DEF. Let's look at the next example. Now notice, guys, we're not having anything marked in for this one. But I can mark in a couple of angles that we know. I notice that we have a bow tie, right? Kind of looks like a bow tie, which means these two angles right here have to be vertical angles. That's the best way to point out a vertical angle pair, is if you have this bow tie looking shape. So those are vertical angles. Also, another thing I notice, I have parallel lines. So that is what those little arrows are meaning. So if I extend my parallel lines so I can actually see them, like that, and I'm going to extend my transversal, the line cutting through. Now, angles pairs in our parallel lines. We can do a lot more with that. One thing, if you kind of turn your booklet to the right, you'll be able to see it kind of up and down. I have alternate interior angle pair right here and right there, right? And I also have them right there and right there. Now, ultimately, I'd only mark out one because I would have AA similarity by that guy and those two. But technically, AA similarity, if two of the angles are congruent, you get the third angle congruent no matter what. So if you can get all three, then you just even have a better chance of saying, you just have multiple ways to say that you know it's AA similarity. So we know we are similar by AA. And let's go ahead and write our statement here. Now this is where these circles are going to be kind of helpful. So we got GKH, let's go ahead and do that one. GKH is similar to triangle. Now I started with two circles, went to one circle, went to three circles. So I got to do the same thing over here. So I got to go NKM. Careful on these ones, guys. These are the two that I think are a little hard, just based on making sure you're following the same pattern of your letters as you followed on one side, just because sometimes they are just a fold over and they're the same, or sometimes you kind of have to twist them and make them lock. Kind of like that. Let's look at the last example. This one we're going to do some algebra on as well. So immediately I do notice we have angle O congruent to angle H, and angle M congruent to angle G. So I do have AA similarities, so we can write they are similar by AA. Now let's write our triangle similarity statement. So we have OMN is similar to triangle. We gotta start with 2, 1, none, so 2, 1, none. HGI looks like that. Now, let's solve for x and for y. So we need to do some setup, because remember, if I can prove two triangles similar, that means my sides are proportional. So, I'm going to go big triangle to little triangle. So I noticed that 16 and 12 are available to be over one another. So I'm going to go 16 over 12 equals, let's do x over 10. There we go. Let's cross multiply. I'll get 160 equals 12x. Looks like I gotta divide by 12. What is that? Let me get my calculator here quick. I get 13.3 repeating, so I'm going to round to the tenths place, aka 1 decimal place. 13.3 would be my answer for x. Now they also wanted y, so let's go ahead and set it up. I'm going to use the 16 over 12 again. Something to keep in mind, do not use a measure that you just found unless it was a perfect, so unless this would have been 13, then I could have used the 13 and the 10. But if it is a decimal, don't reuse. Always use something that you already know for a fact you didn't round. Otherwise, you're kind of rounding on top of rounding, and that's just not good math. And then I get y over 8. So if I multiply 16 times 8, I get 128. 12y, going this way. Looks like I need to divide by 12. So y equals, I don't think that's going to come out nice either. 10.6 repeating, so I'm going to round to 10.7, because I'm rounding to the first decimal place, 10.7. Thus we have found our x and our y of our two triangles. And that's the end of this video. See you later, Sabers.